Okay, so we need to start with partial pressure in today's class. Partial pressure आपके पास जो है एक नई चीज है आपके पास इस चैप्टर में that you need to understand. For example, if you have block, ठीक है ना, ये आपके पास एक कंटेनर है. For example, if you have any container over here, so यहाँ पर आपके पास आपने कोई गैस fill कर दिया, right? You have hydrogen gas over here. This is hydrogen gas, right? And for example, you also filled nitrogen gas over here, right? And you also filled nitrogen gas and ammonia gas over here, right? So we have multiple gases over here. We have 3 different gases over here, and definitely the molecules of gases, they start moving randomly throughout the system. So there will be like over here different molecules of different gases will move on different ways, right? So it will be like this. Over here, a lot of molecules of gases are moving around over here. It depends how much each gas over there, right? So every gas molecule move randomly, and they just be a part of this system, right? Like this. They are just moving randomly, and every gas over here is applying pressure on the walls of the container. Every gas particle, every gas molecule applying pressure on the wall of the container. So whatever the pressure is this in this container, whatever the total pressure of the container, whatever the total pressure over here is actually the sum of all partial pressures. This is the sum of all partial pressures, and the partial pressures are actually the pressure from each gas. It is actually partial pressure is actually the pressure from each gas. What is the pressure of each gas? How can we find it out? Partial pressure of each gas. For example, you are going to find out the partial pressure of each gas over here. How can we find it out? We can find it out over here. For example, if the total pressure is given to you, right? So how can you find out the partial pressure of each gas? So here we have nitrogen gas, right? And we have 3 different gases over here. So we need to find out the moles of nitrogen gas, then the sum of moles of nitrogen, hydrogen, and ammonia gas. This is the mole fraction. You can find it out, the mole fraction. And when you multiply the total pressure with this mole fraction, you will find out the partial pressure of nitrogen gas. And same as it is, you can find out the partial pressure of every gas. If you want to find out the partial pressure of hydrogen gas, you can divide the moles of hydrogen by the total moles, right? And then you can multiply by the total pressure. You will get the partial pressure of hydrogen gas, right? For example, you have like this, an example over here. I'm giving you an example over here, and the example is actually what you have. For example, you have air. For example, you have air, and in this container, for example, you have air, right? And if you have 10 moles of air, we know that we have 78% nitrogen over here and 21% oxygen over here, but I'm considering over here 80-20 ratio for the quick answer, right? For example, if we have 10 moles of air, so definitely we have 8 moles of nitrogen, and we have 2 moles of oxygen over here, right? So if I want to find out the pressure of the air, we can find out the partial pressure of nitrogen. We know that 1 atmosphere is the total air pressure over here on our heads. So the moles of nitrogen divided by the total moles into the pressure, right? Which is 1 atmosphere. Same as it is, if you want to find out the pressure of oxygen, it is moles of oxygen divided by the total moles into the total pressure. You can find it out in this way, that 0.8 atmospheric pressure of air is of nitrogen, and 0.2 atmospheric pressure is from oxygen. So the total pressure, if you calculate the total pressure of the air, which is 1 atmospheric pressure in the environment, out of 1 atmosphere, 0.8 is provided by the nitrogen molecules and 0.2 is provided by the oxygen. This is the way, or this is the thing what you are going to learn in KP, right? Which is partial pressure. And if you talk about KP, so KP is actually the constant like Kc. This is partial pressure constant. Right, this is partial pressure constant. Kp is the partial pressure constant, right? That we are going to find out. If you are going to find out the expression for Kp, it is same as it is that you were talking about in case. It is expression of Kc. If you talk about expression of Kc, or if you talk about expression of Kp, both are the same things, right? For example, we have equation SO2 reacting with oxygen forming SO3, right? So you can find out that equilibrium constant expression by this way, that the concentration of product with the power of its coefficient over concentration of reactant with the power of its coefficient, right? Or you can say that stoichiometric number. This is what Kc expression means. And if you want to write the expression for Kb, it is same. You need to write pressure of SO3 with the power of its stoichiometric number, and the pressure of SO2 with the power of its stoichiometric number, and the pressure of oxygen, like this. You just need to use small brackets for this. You don't need to use square brackets, because the special meaning of a square bracket is concentration. So we are not going to use concentration over here. So that's fine if you are using a square bracket, or if you are using small brackets over here. And same for the units as well. You know the concentration unit is mole per decimeter cube. So right now this concentration is square, and over here we have concentration cube, because we have three things over here. So we just have like this 1 over concentration, and the unit will be mole inverse decimeter cube. Same as it is for this as well. We know that if you're talking about atmosphere, or if you're talking about Pascal, any one of them, if you are doing atmosphere or Pascal, it will be 2 over 3. So when we divide this, we know that we just have 1 over Pascal, and when Pascal move upward, it will be Pascal inverse. Right? You can even use in atmosphere, it will be atmosphere inverse. You can even use for kilopascal, the answer will be kilopascal inverse. Right, बच्चों?
सर ये P का मतलब प्रेशर है ना इसमें, PSO3 का।
PO क्या कह रहे हो?
PSO3 जो लिखा हुआ है, इसका मतलब P प्रेशर रिप्रेजेंट कर रहा है।
Yes, it is showing you the pressure of SO3, right?
ठीक है।
Okay, so is that clear, बच्चों? I think you can write expressions now. Can you write this? So this will give you 1 mark in the exam. If you are aware about this, you can get 1 mark for this. Remember, you can use square bracket in Kc only. Over here, you need to use P over here, right? So for example, if you talk about the formation of ammonia, so it is 3H2 plus N2 gives you 2NH3. So if you want to write the Kc expression for this, so it is concentration of NH2 with the power of 2, and the concentration of nitrogen with hydrogen concentration and the power of 3, right, with hydrogen. And if you want to write the expression for Kp, so it will be the pressure of ammonia with the power of 2, and the pressure of nitrogen into, remember this is multiplication, into pressure of hydrogen with the power of 3. And the concentration unit is, the Kc unit is, it is concentration 1 over concentration square. So it will be mole inverse decimeter 6. And if we talk about this, so it will be Pascal to inverse. Right, Bacho? Is that right or not? Right?
Yes, sir.
Now, when you are going to solve the KP questions, which is very important for exam pattern questions, are very important, right? So for example, I am saying that you have the formation of ammonia and 1 mole of nitrogen initially reacting with 3 moles of hydrogen, right? Reacting with 3 moles of hydrogen. This is the initial, and at pressure is initially you have pressure of 8 into 10 raised to the power 6 Pascal, right? And for example, after the reaction at equilibrium, you find 0.7 moles of ammonia. You find 0.7 moles of ammonia. So how can we solve this? Now, if you are going to solve KP questions, remember the same thing you are going to follow. Over here, we know that this is a complete equation. So we need to write this analytically. Then we know that the ice rule, right? So this is initial, this is change, this is equilibrium. We are talking about the moles right now. So moles initially, change in moles, and then moles at the equilibrium. So we know that initially they gave us what? 3 moles of hydrogen and 1 mole of nitrogen, and we know that product is always 0 initially. And then they told us that there are 0.7 moles of ammonia at equilibrium, right? So whatever the moles at equilibrium is actually the moles of ammonia which produce, because initially we have 0 moles of ammonia. So this is the same number which is produced of ammonia. Now you can see this, the relation over here. This is 2:1. The relation is 2:1. So whatever the amount of ammonia is produced, the half of this will be consumed by nitrogen, right? Or not? So you can have this. Definitely there will be 0.35 moles consumed of nitrogen. And if you relate these two things, so whatever the amount of nitrogen consumed, the 3 times greater amount of nitrogen or hydrogen will be consumed. So 0.35 into 3, it will give you 1.05. Now, we know that reactants are consuming and product are producing. So we always add over here and we always subtract over here because they are going to consume. So 3 minus 1.05 will give you 1.95 moles at equilibrium of hydrogen, and this will be 0.65 moles of nitrogen at equilibrium. These are the number of moles at equilibrium, right? Now, we need to sum all moles at equilibrium. So what are the total moles? To find out the mole ratio, we need to find out the total number of moles, and the total number of moles are, when we add all these 3, we will get 3.3 moles. We will get 3.3 moles. Now, you need to find out mole ratio. This is mole ratio. Mole ratio is what? The moles divided by the total moles. Moles divided by the total moles, right? So what is the mole ratio? It is 1.95 divided by 3.3. This is 0.65 divided by 3.3, and this will be 0.7 divided by 3.3. This is the mole ratio. Once we are able to find out the mole ratio, we can find out the total pressure as well, or we can find out the partial pressure of each gas as well, because the number of moles of any gas is actually applying pressure over there ना. तो total pressure में से एक गैस का कितना हिस्सा है, तो उसके लिए आपको ये फाइंड आउट करना जरूरी है कि टोटल मोल में से उस गैस के कितने मोल्स हैं. दैट इज व्हाई इफ यू वांट टू फाइंड आउट पार्शियल प्रेशर्स, अगर आपको पार्शियल प्रेशर्स निकालने हैं, so you can find out it by multiplying the total pressure with mole fraction. So mole fraction into total pressure will give you partial pressures, right? So we need to do what? We need to multiply total pressure over here, which is 8 10 raised to the power 6, and over here as well, which is 8 10 raised to the power 6 over here, and over here as well, which is 8 10 raised to the power 6 over here. So this will tell you each and every partial pressure of gas and what are the values. If we calculate the values, check the values बच्चों, अगर उसकी values calculate कर रहे हो तो क्या values आ रही हैं. Okay, where's the calculator? Here it is. So we are talking about 1.95 over 3.3 into 8 10 raised to the power 6. 8 10 raised to the power 6. So it is telling us the value of the pressure of hydrogen. Partial pressure of hydrogen is actually 4.72 10 raised to the power 6. And if you talk about the partial pressure of nitrogen, so it is actually 0.65 divided by 3.3. So it is telling us it is partial pressure of nitrogen is 1.57 10 raised to the power 6. And if you talk about partial pressure of ammonia gas on the total pressure, what is the effect of partial pressure of ammonia? It is 1.69 10 raised to the power 6. This is the partial pressures. And if you want to find out the value of Kp, so you can find it out. You know that it is pressure of ammonia with the power of its stoichiometric number, pressure of hydrogen with the power of its stoichiometric number, and the pressure of nitrogen. So over here it is 4.72 square 1. Sorry, ammonia is 1.69 square over 4.72 square into cube. Sorry, hydrogen is 3 and nitrogen is 1.57. I'm not using the values over here 10 raised to the power because all the powers are same, so that is why I'm not using this. It is 1.69 square over 4.72 square into 1.57. So the answer over here is KP का आंसर आपके पास क्या बचा? 81.65 10 raised to the power -3. Is that okay,
0.01 नहीं आएगा, 0.017.
हाँ, वो 10 की वैल्यूज की वजह से आ रहा है क्योंकि ऊपर चेंज है नीचे चेंज है, तो आई नीड टू पुट द वैल्यूज ऑफ 10 ओवर हियर एज वेल. ये कर लेते हैं क्योंकि 10 की वैल्यूज अलग अलग हैं, so we need to put values of 10 also over here. So it is ये आपके पास आ रहा है 81.6563 at the value of -9. ये आ रहा है, चेक करो आपके पास क्या आ रहा है. ये आ रहा है
सर 0.0173 नहीं आएगा.
देखो मैंने कैलकुलेटर मिस किया है या आप कर रहे हो, चेक करो. Okay, so I have calculator over here, so I can do this. Ammonia is 1.69 10 raised to the power 6, and this is square. And if you talk about the second one, is the pressure of hydrogen, which is 4.72. 4.72 10 raised to the power 6 square into 1.57 10 raised to the power 6.
सिर्फ 4.72 रेशो पर क्यूब नहीं होगा.
4 point
4.72 raised to power cube 3 है ना?
It's 3, right? यार आपके पास 1.73 10 raised to the power 14 है ना?
सर 0.0173 आएगा ना, अगर सिंप्लीफाई करेंगे तो।
यार आपके पास 1.73 नहीं आ रहा?
सर 1.73 आ रहा है अगर आप वो 10⁻6 ऐड करते हैं, लेकिन नॉर्मल वाले में 0.0173 आ रहा है।
अच्छा जी, वैसे आज का आंसर आपके पास क्या आ गया? द वैल्यू ऑफ केपी इज 1.73 10 raised to the power -14, राइट? जो मेरे पास आंसर आ रहा है वो ये आ रहा है, which is the right answer। तो मेरे मोबाइल से क्यों गलत आ रहा था भाई? कैलकुलेटर से ये आंसर आया है, मोबाइल से अलग, ऐसा क्यों हुआ? Okay, so maybe there is some mistake in a mobile phone calculation. So the right answer is KP is 1.73 10 raised to the power -14. And what is the unit? If you talk about the unit, so you can see this कि आपको इनिशियल यूनिट जो क्वेश्चन में गिवन है वो पास्कल गिवन है, ठीक है ना? तो ऊपर स्क्वायर नीचे 4, so it will be Pascal 2 inverse, राइट बच्चों? Right?
Yes, sir.
Okay, so this is the type of questions you will find in KP, right? और इस तरह के क्वेश्चंस आपको मिलेंगे तो आपको सॉल्व करने आने चाहिए। बहुत मजे के क्वेश्चंस होते हैं, आपको मार्क्स यहाँ मिलते हैं और आप इजीली इसको सॉल्व कर सकते हो और आराम से आप केपी के क्वेश्चन में मार्क्स ले सकते हो। देखो फॉर एग्जांपल वी हैव वन मोर एग्जांपल ओवर हियर, वो भी करते हैं ताकि हमारे क्वेश्चंस क्लियर हो जाए। फॉर एग्जांपल इफ यू हैव a equation like this, carbon monoxide reacting with nitrogen monoxide forming carbon dioxide and nitrogen gas, right? For example, the equation is like this, and what are the informations? The informations are, they are saying the chemist mix 0.46 mole of carbon monoxide with 0.45 moles of 0.46 moles of carbon monoxide and 0.45 moles of nitrogen monoxide, right? And they are saying when the mixture is left to reach at equilibrium, they are saying when the equilibrium reaches and constant temperature, what will be the other information they gave us? They gave us that 0.25 moles of nitrogen monoxide remain. 0.25 moles of nitrogen monoxide remain, and this is at equilibrium. At equilibrium, right? And the total pressure they gave us is, total pressure is like 5 atm. They gave us the total pressure 5 atmosphere. Now they're asking what is the value of Kp. Now that's not a big deal for us. We can write equation over here, right? This is the equation. Carbon dioxide and nitrogen gas, initial moles. Initial moles we have 0.46 and 0.45, and definitely products are 0, and then change we need to find out, and then equilibrium moles. So they gave us the moles of nitrogen monoxide remain at equilibrium, which is 0.25. So you can see this, that how much is used up. If nitrogen monoxide 0.25 remain, so definitely 0.2 moles are used up. And you can see the relation is same for both of them, carbon monoxide and nitrogen monoxide. So definitely the same amount of carbon monoxide is also used, and when you subtract, so you will find 0.26 moles of carbon monoxide remains. If you take the relation with carbon dioxide, so the same amount of carbon dioxide will produce. This is the production, so there will be addition. So that at equilibrium, you will find 0.2 moles of carbon dioxide. And if you talk about the relation with nitrogen, so it is the half of this. Now, if you are using 2 moles of nitrogen monoxide, so 1 mole of nitrogen is produced. So definitely 0.10 moles of nitrogen produced, and it will be the moles at equilibrium. Right, Bacho?
Yes, sir.
Okay, just calculate the total moles and then find out the partial pressure. And after this, right? So find out the total pressure. Find out the total number of moles, right? And the total number of moles are 0.5, 0.8. I think it should be 0.81. And when you find out the mole fractions, so mole fractions are like you need to divide all of them by total number of moles. And when you find out the partial pressure, you need to multiply all of them with 5 as well. And then you need to put the value of partial pressures in the KP equation, right? So right now it is 0.26 divided by 0.81 into 5. The answer is 1.6, right? If you talk about 0.25 divided by 0.81 into 5, it will be 1.54. If you talk about 0.2 divided by 0.81 into 5, so it will give you 1.25. If you talk about the last one, so 0.1 divided by 0.81 into 5, it will give you 0.617, right? So write down the expression for Kp, and it is the product pressures, which is carbon dioxide, over the value of their stoichiometric number, and the pressure of nitrogen over pressure of carbon monoxide and pressure of nitrogen monoxide, right? Put the values, get the answer. So these are actually carbon dioxide is 0. It is 1.25 square into 0.617 over 1.6 square into 1.54 square. It is 1.25 square into 0.617. It is 1.6 square into 1.54 square. The answer is over here, Kp, the value of Kp is 0.158. And if you talk about the units, so over here we have 3 and over here we have 4, and the unit is total pressure is atmosphere, so it is 1 over atmosphere, which means atmospheric inverse, right? But is that clear or not?
Yes, sir.
So this is a way to solve some questions of Kp that you need to understand. It's very easy, and it will give you almost 4 to 5 marks in the end. So